Hello students, already we have done with the fuzzy set. Now we want to check what are the different operations we can do on the fuzzy set. So generally the operations on crisp set, what we'll do, we can do union, intersection, complement. Okay, you can check whether the element is contained in the set or element is not contained like that. So how we can do is the same operations and what is the formula for fuzzy sets. So first we'll start the union. So remember one thing, here we are not doing the operations on fuzzy set. We are doing the operations on the fuzzy relations. So that will be R and S are the two fuzzy relations, and then you are doing the union. So what is the union for this? What is the formula for the union? So we have to see RVS, or the relation between union of R and S, where R and S are two relations. Remember this point. Maximum of R of u comma v and S of u comma v. Okay. So here example, mu of R union S. If I take here variable, here it is u comma v, here it x and y. It does not matter. So R union S equal to x comma y of max of mu R of x comma y comma mu S of y comma z. So it may be any variables. So only thing you have to remember is you have to find out the maximum value between the two relations, not the sets. So if we go for the example, suppose the relation between R and S, X is considerably larger than Y. So what is this? We have done all the crisp relations in the previous session, right? So here the relation between X1, Y1 is 0.8, X1, Y2 is 0.1, X1, Y3 is 0.7. So that we can know. So this is a R. Similarly, X is very close to Y. This is another example. So X1, Y1 0.4, okay, X1, okay. Now what is our, how we will find out the maximum? Okay, so if you see here, just an example, here the relation are x1 y1, it is 0.8. Now here the relation between the x1 y1 is 0.4. So which one is maximum? 0.8. So this will be the union. Okay, so the union of R and S statement means x is considerably larger than y, or x is very close to y. So union implies or, right? Intersection means and. Okay, so one more example I'll tell you, just x1, y2, it is 0.1. If I take here, x1, y2 is 0.0. So what will be the maximum? Actually, it is 0.1. Okay, so it was some printing mistake, so please change. And third one is x1, y3 is 0.1. And x1, y3 is 0.9. So max is 0.9. Okay, so like this we can find out the union. Only thing you have to remember is the maximum of value between two relations, not between two sets. So this is the example for union. Now intersection, same as it is, only the thing is we have to find out the minimum. So the relation between the minimum value between the two relations will come under the intersection. So I'm repeating the same example. Here it is 0.8, here it is 0.4. So what you will get? 0.4. Done. So if you go for the second value, 0.0 over here, it was 0.1. If you see here, it is 0.1. So which one is minimum? You should get 0.0. So like this, whenever you intersection, this is a symbol. As I said, we will repeat this like and. There we got or. So this is intersection. Now coming to the complement. So generally what is a complement? Mu minus mu. If you take the universal of this course as u, so then you will take 1 minus u. Sorry, 1 minus your elements. Suppose if I take in this example, so you will take the value R complement equal to 1 minus what is the relation R. So I remember the value was, for example, if you take here the value was R, in that relation it was 0.8. Now what is the value now? 1 minus 0.8 equal to 0.2. So this is the complement. I think this was 0.1. So yx1 comma y2. So here it was 0.1. Now what I am getting over here, 1 minus 0.1 equal to, you will get 0.9. So this is the solution for the complement. Okay, so this will be the solution for the complement. Like this, whatever the relation we have, you can calculate. Next operation, containment. So remember here one thing, it should be less than or equal to two relations here. This is R subset of S. I'm checking whether R is contained in S. So in that case, mu R of x comma y should be less than or equal to mu S of x comma y. Then only R is contained in S. So if you take an example, okay, I'll give an example over here. Suppose if I take our relation between like x1, y1, okay, it was 0.3. Same example, x1, y2 in x, it was 0.4. So here 0.3 should be less than or equal to 0.4. Then you can say that R is contained in S. Suppose if the same example, the value was 0.4 and it is less than 0.2, I'll say that R is not contained in S. So this is called as containment property or containment operation. Okay. So we have done with the union, intersection, complement. So union means maximum value of relations, minimum value of relation is intersection, 1 minus the relation is complement. Now, coming to the next one, projection. So this is very interesting. Please, all of you try to understand. So what is projection over here is, suppose if I take here x, one second now. So here if I take this one, x part. So it was 0 0.3, 0 0.8, 0 0.7, 0 0.5. 0.5. So what is the maximum? So it is 0.8. Got it? This is x projection of x. Now, what is the projection of y? If you take y1, so y1, you have to work in this direction. If you see this direction you have to check. So the value was 0 0.3, 0 0.7, 0 0.9. So which one is max? 0 0.9. Okay. If you go for, okay, I want to work on one second. I want to work on second one, y2. Okay, you want to work on y2. Suppose if I take the projection of y2, so y2 equal to, what is the value? 0 0.8, 0 0.3, 0 0.0. So what is the max here? 0 0.8. Done. So these are the projection values. So projections will be two projections. One is x direction, one is y direction. Okay. So this is related to projection. Now, the next operation will be on composition. So this is very important. Just I'll tell you the formula for this. If I take the complement over here, all of you look at here, R circle S. R circle S is a relation, composition of two relations. See, okay, one second. I will go this, that will be better. Yeah. So what is a relation? First, starting with the relation. One second. Done. Suppose if I do two sets x cross y, this is called relation. Okay. Here x1 consists of x1, x2, x3. Y consists of y1, y2, y3. Done. Now, again one more relation, S equal to y cross z. Again here it consists of y1, y2, y3 and z1, z2, sorry, z3. Done. Now, these are two relations. Now, what we are going to do in composition, I am combining two relations, R circle S. This circle implies composition. Okay. So this composition, how to find out? For this, we have two types, max min and min max. So max min, sorry, min max. So you have two types of compositions, max min and min max composition. So this is exactly what I want to convey here. So if you take this one, R circle S is the formula. So here you will have the two, oh, one second. Yeah. So what is the formula? Please look at over here. So max, first you have to calculate the minimum between two relations, mu R of x comma y, mu S of x comma y. If you see here, mu R of x comma y, that is in the relation R, mu S of y comma z. So where R belongs to relation between x cross y and S belongs to relation between y cross z. After finding out all the minimum values, you have to find the maximum. So this is called as maximum. Suppose, same example, if I first min will be outside, then max will be inside, then it is called as min max. That's it. So remember, first we'll find out the minimum values between the two relations, then find out the maximum value. In the other case, first we'll find out the maximum value, then we'll go for the minimum values. If you see the example over here, so here it is a relation between R, okay, fruit example or already what we have discussed. So the relation between green and verdant is 1, green and half mature is 0.2, and this one. So when I go for the next one, okay, one more relation, okay, yeah, 1 second. So if I come here, there the relation was between this side we had, okay, green, I'm writing half mature, okay, verdant, okay, I'm writing some value over here. Now if you check this one, I'm taking this verdant here, I'm telling taste. So it is exactly like transitive property. So A is related, green is related to verdant, verdant is related to taste. So implies green also related to taste. So don't worry about the transitive property. Now, if you see here, you will get the all values. If it's verdant, what is the probability of source? 0, 1. 0.2 is tasteless, 0. Now, finally, after finding the composition, what I'm doing here, I'm taking the first one green. I'm telling whether it is sour or whether it is tasteless, whether it is sweet. How I am doing? By finding the min-max compositions or maximum composition. So simply you have to substitute all the values in this particular equation, then we will get this output. Okay, so this type of compositions, we have two types, min max and max min. Okay, yes, so this is done. So what we have discussed, 1 second, only one second we can work on it. Yeah, so we have find out the union, intersection. Okay, then complement. Okay, then we have done projections. Okay, composition. So this is our session, right? So I hope you will practice all the examples. Okay, so thank you.